Okay, I want you to picture three things just sitting on a table: a nuclear reactor, a little cracked plastic lever from a car door, and a 9-carat gold ring.
That sounds like
Yeah.
I don't know, the inventory list for a very chaotic video game.
It really does. But according to the research we're digging into today, these three objects, they sort of explain why the last decade of innovation is about to hit a serious brick wall.
Mm.
We're diving into a stack of notes from this persona. They're called the Quiet Architect. It's this blend of mechanical engineering, AI strategy, and industrial design. And the central idea is, well, it's a bit uncomfortable.
Uncomfortable is definitely the right word, because it basically says, stop learning to code, or at least stop thinking that code is the answer to every single problem.
That's a pretty bold way to open a tech deep dive.
It is. The argument here is that the whole era of digital-only disruption is just.
Yeah.
It's over. We've optimized the bits. Now we're crashing right into the atom.
Yeah.
Yeah, the next trillion-dollar companies won't be pure software companies. They'll be the ones figuring out how to merge digital intelligence with the messy physical world. We're talking energy, manufacturing, raw materials.
So it's less move fast and break things and more move carefully and build things that don't break in the first place.
Precisely. And our mission today is really to look at those bottlenecks. We're going to try and debunk some of the AI readiness hype and look at the unsexy stuff infrastructure yield rates that will actually decide who wins and who loses come 2027.
Let's start right there. 2027. The source material is waving this huge red flag about that date. It says, forget chips. Your bottleneck is kilowatts.
This is the most critical pivot in the whole stack. I mean,
Yeah.
right now, if you walk into a boardroom in Silicon Valley, everyone is just screaming about GPUs.
How many H100s can we get?
Exactly. But this source argues that the real meeting, the important one, it doesn't happen at NVIDIA. It's happening at the local utility company.
Because AI is just so hungry.
It's voracious. We are seeing this head-on collision between AI's demand for constant, incredibly dense compute power and an energy grid that is, frankly, it's old and it's tired.
Right.
The hyperscalers, Google, Microsoft, Amazon, they saw this coming a couple of years ago. They aren't just buying backup batteries anymore. They are actively hunting for baseload power.
Okay, help me out with baseload. Why not just build more solar farms? Everybody loves solar.
And solar is great, but it creates variable power. The sun goes down, cloud passes over. If you're running a massive AI training cluster, that thing needs to be at 100% capacity, 247.
You can't just tell a training model to, take 5 because it got cloudy.
You can't. The compute density is so high that if the power fluctuates even a little, the whole operation could fail. That's where the source points specifically to nuclear PPA's power purchase agreement.
And SMRs, what are those?
Small modular reactors.
Right.
So think of them like factory-built nuclear plants you could literally ship on a truck. And the prediction here is financial. The stock market premium in the late 2020s, that extra 15–25% valuation, it's not going to go to the company with the cleverest chatbot. It'll go to the company that has a dedicated SMR just humming away, keeping their farm running when the public grid starts to brown out.
That totally flips the script on what a business moat even is. Usually it's a brand or a patent. You're saying the moat is an electron.
The moat is reliability. 100%. If you're reliant on the public grid, your costs are all over the place, your risk is high. If you own the reactor, your cost is fixed.
So the source lays out a kind of strategy roadmap here. It mentions 3 layers for anyone building for 2027.
Right. Layer 1 is source. Where do your electrons actually come from? Layer 2, the cost curve. Is your power cost fixed or is it variable? And layer 3 is the really chunky one. Regulatory risk.
Which is basically asking, will the local government even let you build this thing?
Exactly. The advice is to stop making slide decks about synergy and to actually identify a pilot region, a specific place on the map where the politics and the physics line up so you can secure that nuclear-linked power. It's not science fiction anymore. It's just procurement.
Okay, so step 1 is just keeping the lights on. But let's move from the power plant to the industrial park. The Quiet Architect notes have this whole section on the unsexy AI revolution.
I love this part. While everyone is completely obsessing over the latest text generator, there's this company called AMP Robotics. They didn't try to write poetry. They raised $91 million to teach robots how to look at trash. Recycling, to be specific. They deployed computer vision systems, cameras basically, hooked up to AI to sort different kinds of waste on these fast-moving conveyor belts.
And I'm guessing that's way faster than a person.
So much faster.
Yeah.
And, it doesn't get tired, it doesn't get hurt. But here's the real insight. The value isn't just in the sorting. It's in the data.
Oh,
Suddenly, a waste management facility knows in real time exactly how much plastic versus how much aluminum is passing through their system. They turned a garbage stream into a data stream.
that seems to be the pattern here then. The big opportunity isn't in what we think of as tech industries, it's in the industries my grandfather worked in.
Waste management, construction, agriculture, yeah. These fields are just drowning in inefficiency. The source argues that boring is where the real money is. Don't build AI for the sake of AI. Find a huge, dirty, expensive problem and just throw computer vision at it.
But there's a catch, right? We're merging digital and physical, and the physical world is, well, it's unforgiving.
It is. You can patch code from anywhere in the world. You can't patch a cracked axle over Wi-Fi.
There are two case studies in these notes that illustrate this just perfectly. First, the EV battery mystery. It's from Bengaluru. Walk us through this one.
Okay, so you have this team of brilliant firmware engineers. They're building a new electric vehicle. Their code is perfect. The battery chemistry is solid. But in real-world testing, the battery's dying in 2 hours. It should be lasting for 8.
Ouch! So they must have thought it was a software bug.
Of course. They spent weeks just tearing apart the code. They assumed it was a memory leak, maybe a background process that went rogue. Finally, they pull the dash cam logs, and they realize the car's main computer was waking up over and over and over again, thousands of times.
But why?
Because the car thought the door was opening.
It thought the door was opening.
This is where the physics get you. Deep inside the door latch mechanism, there was this tiny plastic lever. It probably cost 10 cents to make. But the supplier had used a cheap, substandard plastic, and it developed a hairline crack.
So the lever wasn't breaking completely, it was just fluttering.
Exactly. It would just wobble a tiny bit, and that would trigger the sensor. Now, in software terms, that sensor sends an interrupt signal to the main computer. It forces the computer to wake up from its deep sleep mode to check the door status. And that wake-up cycle, it draws a huge amount of current.
So it's like someone is ringing your doorbell every 3 seconds all night long. You never actually get to sleep.
And that just drains your energy. A single 10-cent piece of plastic created an interrupt storm that completely wrecked the performance of a $1 million software stack.
And that's the lesson right there. Firmware alone won't save you. In the physical world, your amazing software is only as good as your cheapest, crappiest mechanical part.
It's a brutal reminder, you know. You just can't code your way out of bad hardware.
Which brings us to the second example, which is oddly beautiful. It's a gold ring.
Yeah, this is the Pure Taper project. It's basically a mechanical engineer applying industrial manufacturing logic to jewelry design. He wanted to design this gold ring with a very matte, minimalist finish, very Gen Z, but he treated it like a production problem, not an art project.
How so?
With traditional jewelry, you often have to solder pieces together, and soldering creates weak points. It requires really skilled manual labor, which introduces variability. This engineer decided to use something called investment casting to make the entire ring in a single, solid piece.
One piece of metal, no seams.
Right. But that is incredibly hard to design because molten gold, it flows in very weird ways. If the geometry is even slightly off, you get these tiny air bubbles porosity. So he had to run simulations of the metal flow to guarantee a 100% yield.
So he basically engineered the ring to be unmess-upable.
That's the entire quiet architect philosophy in a nutshell. Great design isn't just how does it look, it's how reliably can I manufacture 10,000 of these without a single defect. Whether it's a car door or a wedding ring, the physical constraints, they dictate your success.
This leads to a story in the notes that really stopped me in my tracks. It's about a robot and a grenade.
It's a heavy story. The author talks about visiting this factory where workers were handling high-grade explosives, literally handling grenades by hand. And you could just see the sweat, the tension in the room. These people were terrified.
So he built a robot to do that job.
He did. But the point of the story wasn't, look at my cool robot. The takeaway was, real technology doesn't replace people. It restores them. The entire goal was just to send that welder home at the end of the day with his nerves intact.
It totally changes how you should look at the user.
It does. And the source has a name for these people. It calls them tracer users.
Explain that concept, tracer users.
So most companies, they try to design for the average user, the mainstream. The tracer theory says, ignore the average. Go find the 5 people whose lives are absolutely fundamentally fused to the problem. Like the guy holding the grenade.
I see.
If you solve the problem for him, the solution will be so robust that it works perfectly for everyone else.
It's like the curb cut effect. You put a ramp in the sidewalk for people in wheelchairs, but it ends up helping parents with strollers and delivery guys with carts.
Exactly. You design for the extreme case to fix the entire system for the mean.
Hmm.
And to do that, you need a very specific kind of team.
The Renaissance workshop.
That's the term, yeah. And there's a fascinating MIT study cited here. It found that AI can be the great equalizer for diverse teams.
How? In what way?
Well, it found that when teams use AI, the whole pedigree gap just vanishes. It doesn't matter if you went to an Ivy League school or a community college. The AI provides the baseline knowledge for everyone. So value shifts from what facts do you know to how good are your questions. It lets diverse teams surface the best ideas about 70% faster.
Let's pivot to the digital side for a minute. If we're building these incredibly complex systems, we have to secure them. And the source says our current security model VPNs is basically a security blanket.
Yeah, and a security blanket implies it makes you feel safe, but it doesn't actually protect you. The old model was the castle.
Yeah.
You build a big wall, that's the VPN, and once you're inside, you're trusted.
But remote work completely shattered that wall.
The wall is gone. The new model is called Zero Trust. It sounds paranoid, but it's really necessary.
Yeah.
It just means the system verifies who you are continuously, not just when you log in.
Give me an example of what continuous verification looks like.
Okay, let's say you log in from New York at 9 in the morning. Then at 11 a.m., your same credentials are used to access a server from Shanghai.
Physically impossible.
Right. A dumb old system just asks, is the password correct? A zero trust system looks at the behavior and says, that travel velocity is impossible, block it. Your identity becomes the new border.
Speaking of interacting with these systems, we need to talk about God-level prompting.
The name's a little dramatic, I'll give you that. But the technique is solid. It's formally called recursive metacognition.
That sounds like a massive headache. How do I actually do it?
It's easier than it sounds. Most of us, we ask an AI a question and we just take the first answer it gives. Recursive prompting is just about asking the AI to critique itself.
So I just type, "Are you sure about that?"
A little more structured. You tell the AI something like, break this problem down into steps. Now, generate 3 different possible solutions. Then, I want you to critique each of those solutions and tell me their flaws. Finally, give me the best one.
You're forcing it to show its work.
And to grade its own homework. The notes say this technique improves performance by about 110%. It turns a simple chatbot into a whole panel of experts debating your problem.
I want to apply this system thinking to something much more mundane. The source has this whole section on the Provident Fund, or PF. Now, this is specific to India, but I think the lesson here applies to anyone, anywhere, who's dealing with a big bureaucracy.
It really does. So the PF is a mandatory retirement savings program. The problem is that some companies, they deduct the money from your paycheck, but then they fail to deposit it into the government account.
Which is theft, plain and simple.
It is a criminal breach of trust. But most employees, they feel helpless. They just wait and hope. The quiet architect approach says, don't be an NPC, a non-player character in your own life. Understanding the rules of the system is what gives you leverage.
So what's the cheat code in this situation?
It's a speed run of the bureaucracy. Think of the legal system as a computer program. It has inputs and it has outputs. Step 1, information. Check the official app to confirm the money is actually missing. Step 2, escalation. Don't just complain to HR. File a formal grievance on the government portal.
And step 3 is the nuclear option.
Right, which is...
filing an FIR, that's a police report. And you specifically cite sections 4A6 and 409 for criminal breach of trust.
That escalated quickly.
It's not about being aggressive, it's about understanding the API of the real world. If you know the specific input, section 409, the system is forced to generate a specific output, whether it's an energy grid, a car door sensor, or a labor law.
The system runs on rules, and if you don't know the rules, you're a victim of them.
Exactly. Most people stop at the user interface, the HR department, the complaint form. The architect goes straight to the code level, which in this case is the law itself.
So we've covered nuclear reactors, recycling robots, cracked plastic, and labor laws. How do we tie all of this together?
I think it comes back to that distinction the source makes between a feature and a utility.
Break that down for me.
A feature is cool, it looks great in a pitch deck, it gets you some buzz. A utility is essential, it just works. It keeps the lights on. The quiet architect is challenging all of us to stop building features. Don't just build another wrapper around ChatGPT.
Go deeper.
Find the real bottleneck. Find the place where the atoms are failing the bits. Maybe it's the power source. Maybe it's the manufacturing yield. Maybe it's the dynamic on your team.
The winners of the next decade won't be the ones with the flashiest demos. They'll be the ones who actually figured out how to make the entire system work end to end.
From the electron all the way to the algorithm.
So I guess that's your homework. Look around for the unsexy problems, the ones hiding in plain sight. Thanks for diving in with us.
See you next time.